Hello and welcome to section 5.4, exponential functions, differentiation and integration. And so I'm going to get into a little differentiation, but first we're just going to practice solving this equation. And you need to remember that that if you have ln of e to the x, your answer ends up being x for that. And so that ln and e are inverses of each other. So the first thing I'm going to do is just try to isolate e to the x. So I'm going to subtract 1 from both sides. And so I get 6 equals e to the x. Oh, whoops. Oh, well. And so then I can do ln on both sides, so it'll be ln of 6 equals ln of e to the x, which basically means the ln of 6 is what x is. Now, how would this change if the problem was 7, which equals e to the x plus 1? Not much. I would still natural log both sides. That would be my first step, is I would take the natural log of both sides, so the natural log of 7 equals the natural log of e to the x plus 1, but then I would get the natural log of 7 equals x plus 1. And then I will subtract the 1 after that, and so I'd get minus 1 plus the ln of 7 will equal x. And if I did that, x would come out to be approximately 0.946. And so it just depends, but it's just solving the equation algebraically, and just you have to remember that ln is the opposite of e to the x, just the opposite operation. So again, here we go. If we have ln equals 2x minus 3 equals 5, well, first thing I'm going to do is I'm going to turn this into an turn these both into exponents. And so e to the ln, remember, is opposite operation, so they'll cancel each other out. So I really have 2x minus 3 equals e to the 5th power. And then what I'm going to do is I'm going to add 3 to both sides. And so then 2x will equal e to the 5th, and then plus 3. And then I get to divide everything by 2 to get my final answer for x equals e to the 5th plus 3 all over 2, which means that x is approximately 75.707. And so that's really all we're doing. We're just solving algebraically, remembering that e and natural logs are opposites of one another. So then, here's the derivative function, and so we have this. If we take the derivative of e to the x, we get e to the x. If we take the derivative e to some function, u, then we take u prime times e to the u. So here we go. Here's they're asking me to take the derivative of this, and so if I'm going to take the derivative of e to the 2x, so if I just said y equaled e to the 2x minus 1, and they said find y prime, I would say y prime will equal, well, e to the 2x minus 1 is what I get back, and just you have to remember that u is 2x minus 1, so u prime would be 2. So I'm going to multiply by 2, and so my final answer for that one ends up being 2 e to the 2x minus 1. And then down here, if I was to go ahead and find the so for this one, again, I'm going to have to say, well, my u value in this case is negative 3 over x, or I could write it as u equals negative 3x to the negative 1, and so then u prime, if we remember, we're going to multiply by the power, which makes that 3, and then we reduce the power by 1, which turns it into negative 2, so u prime could be written as 3 over x squared. So now when I take the derivative of this function, which is e to the negative 3 over x, y prime, I multiply by u prime, which would be, the u prime would be 3 over x squared, and then I just rewrite the function that I started with. And so that would be the derivative of this function right here. And that's really all we're trying to do. We could manipulate its placement, but other than that, that's really all we're looking at. So then the final one is to find the relative extrema of this function. And if I'm trying to find that, remember we're looking for a max or a min. And basically the max or min is when we set the derivative equal to 0. So we're going to have to go ahead and find the derivative of this function, and then we could do a first derivative test to find out what's happening. So I'm going to say f of x equals x e to the x. Now you may notice that there's an x times e to the x, which means I'm thinking I have to do a product rule. So f prime means take the derivative of the first, which is e to the x, add on, leaving the first alone, and raising it and multiplying it by the power of e to the. And so this is just following our rule that we have. And so I could factor out e to the x, which means that my f prime of x will equal e to the x times 1 plus x. And so we want to set this guy equal to 0. And remember my zero product property. And basically, e to the x is never actually 0. The derivative is only 0 when x is negative 1. And so, since e to the x is always a positive number, there's no way I can make that 0, so that's really not going to equal 0. So e to the x is not going to equal 0. But I could make the 1 plus x equal 1, and that's where I get my x has to be. So I could say 1 plus x equals 1 equals 0, which is using my zero product property. And I just remember that e to the x will not give me a 0. And so, and if you don't believe me, graph e to the x and look at it and see what it looks like. But this one, if I solve, then x will equal negative 1. So I'll have an extrema, I'll have a max or a min at x equals negative 1. Now, if I was to find out whether this was a max or a min, I would end up doing a first derivative test around there. And so I'm going to say, okay, well, here's negative 1. And so I would do f prime of, say, negative 2, and probably f prime of 0. And putting in 0 into f prime will give me 1 times 1, which gives me a positive number. And then if I put in negative 2, I get a negative number here. And remember, it doesn't matter what value of x I put in here, I'm still going to get a positive number. So e to the negative 2 is positive. So I have a negative times a positive, which means I end up with a negative number. So my graph is decreasing and then increasing at negative 1. So that means that x equals negative 1 is a relative minimum. And so if you have any questions about these, come to class, be prepared to ask about them, and we will talk more about it. And you can see that at x equals negative 1 would be a relative minimum. But we'll talk about these. So.